Hello, in this video we're going to demonstrate how to create a footprint from the data in a PDF datasheet. To start with, we will click create a new footprint, and instead of selecting a template, we'll just use the blank footprint option. From there, from our blank footprint, we'll go to tools and import data from a PDF. And from there we will use the file buttons to browse for a data sheet to extract the data from. We'll use this one here for this LGA style part here. You will want to use the copy area. You can use the copy page, and you can see it populates with the entire page, but we'll just use the copy area to get the exact kind of land pattern. One thing we'll also want to note is that the body width is 5 millimeters. We'll use that later when we need to scale this data. But once it's populated, you can close that window, and then we will auto center and then select a layer to place it on. We'll just place it, let's see, on the top assembly layer, and then click copy all shapes to layer, and now you can see the data that will be imported into the footprint. If we already had data in the footprint before we selected the PDF, it would have the existing data here as well. So then once you click done, we'll be given an option to scale, but we'll just leave it at 1:1, and we'll do a scale by measure using that 5 millimeters as the width. But first, we'll go ahead and do that using the scale by measure, and we'll measure measure the length of the side, which we know should measure 5 millimeters. And you can see it scaled. It was already pretty close to scale. Now we'll go ahead and turn the snap on our grid off so we can select some of these stray lines, so we can clean up some of this stuff a little bit better. And once we've done that, one other thing that we want to do is select all the data, and we'll want to flip it horizontally, because the data that we pulled from the data sheet is from the bottom view of the part. So we'll want to mirror the flip horizontal, and that will give us an accurate footprint to the data sheet. So now that we've done that, probably the first thing that we want to do is actually create some pads. So what we'll do, we'll select all of these lines, and then under the lines options, there's a make pads selection. Once selected, it goes through all the lines, and any lines that form a simple polygon, it creates a pad that is sized to fit that polygon. Obviously, it made a pad that fits the entire body size, but we don't need that, so we can just delete that pad, and everything else looks like it populated correctly. You can see all the land shapes for all the pads. Now, one thing to note, that they do come in by default as bullet shaped pads, with the curved edge indicating where the toe of the pad is. So obviously we'll want the toe of the pad pointing to the outside of the part. So for these on the top, they're all oriented correctly, and all these pads on the right side, but these on the left will need to be rotated, as well as these on the bottom. So we'll go ahead and select those and just go to properties, and from there we can set the rotation to 180 degrees, and they'll rotate into the correct orientation. And we'll do the same for these pads on this side. Alright, now that we've done that, we can set a toe heel side for each pad style. It'll be a separate pad style for each orientation. So if you go in and select just one individual pad and then go to the pad style options, there's an add toe heel side, which gives you the options to add the a different toe and a different heel and a different side to this pad style. And it also you also have a pop-up that has the IPC standards for different lead types, but we'll just use the default here. You also have the option to change the pad shape, but we'll just leave it as rectangular. But I'm going to click cancel, because if you click all the different, so if you select all the different pad styles that are on the part and then go to the pad style, add toe heel side, it will add the same toe heel inside to all of the selected pad styles instead of having to come to this menu for each one. So we'll just use the default toe heel side and change the pad style to a rectangle. And now you can see it's added that toe heel, it's increased the pad size on the toe heel inside for all the pad sizes. So from here we also might want to renumber the pins. So we'll come up here and go to renumber pins right up top, and then we will select a starting pin number. By default, it's going to populate with the next available pin number, which, since they all come in with a default of pin number of 0, the next available is going to be 1. So from there, once we do that, we will highlight the pins, and it's going to renumber the pins in the direction that that they're highlighted. So if we go from left to right, the next the next pin number will be 5, 6, 7. And if we go from top to bottom, you'll see the same pattern. So just keep that in mind when you are renumbering the pins. And once we're finished, we'll end that command. Alright, so from here, we've renumbered the pins. Now we might want to make a silk screen. To do this, we can select the outline of the body, and then if we right click, one of the lines options is copy to a new layer. Here we're presented with options. We can select the new layer to copy it to. So if we want to make a silk screen, we would select that layer. We also can select how the excess size or the offset size, so how far outside of this polygon or outside of the current lines do we want to make the new lines. And also we can set a new line width, which we'll just leave to the default of 5 for both of those. And once we hit OK, you can see it drew the lines, and it also kept it the default size away from from the pads, so we don't have the silk screen crossing any of the pads as well. So from here, the next thing we might want is a place bound. So if we select those same lines that define the outside of the body, we can right click, and one of the lines options, click a little farther up, one of the lines options is to make a polygon. And once selected, it does exactly what it says, just takes those lines and uses the borders from the lines to create a polygon. From here we can look at the polygon options, and one is enlarge polygon, which gives us the option to increase the size of the polygon by an excess size of the IPC least nominal max, or we can do a separate user defined, and you can put any excess size that you need. We can also have it move the new polygon to a different layer. So since we're wanting to make this a place bound, we'll select that layer. You can also have it create perimeter lines around the perimeter of the new polygon, and also you have the option to route the new polygon to add that excess size around the pads as well, because you can see the polygon that we've selected that defines the body does not go around the toe of the pads. So if we just added that excess size just to this line, it wouldn't be the correct distance from the pads. So that's another option. So we'll just leave all the defaults selected here, and once we click OK, you can see that it's routed around the pads, and that the IPC nominal size from the body. Um, and we can just delete that the polygon that we started with now. Um, so from here, we might also want to this funky shaped heat tab in the middle. We might want to create a polygon on the top layer um, for that heat tab as well. The easiest way to do this is under Tools, there's a Make Polygon from Boundary area, and once you have selected that, it puts the mouse in a mode where wherever you click, if it's inside of a polygon or inside of lines that form a polygon, it will turn those lines into a polygon. So if we just click anywhere inside of that heat tab, you can see it populates with a polygon that follows the outline of all of those lines. So that's a quick way to create a heat tab from some crazy shapes. All right, now that that's done, we we might want to also create some attributes, place some of those, or if we come up to special point, we also have the option to change the origin, pick and place, or glue dot. For example, if we want to change the origin to the center, you can change it to any of the, as long as our snap is on under our grid, um, any of the snap points, which include the corner of pads, the center of pads, um, the points of a polygon, or the end and start points of lines, things of that nature. So if we wanted to change the origin to the center of the pad, we would just click there and it shifts. Um, we'll or if we want to change the pick and place to this top corner, it makes it really easy. But we'll just change those back to the center um, where those lines intersect. That's also a snap point that is available. Um, but we also have the option under this special point type is to import, place user XLR data, which when selected presents uh, a series of buttons that are user mappable using this button setup here, um, where you can name the button and map it to an XLR file, or you can just simply browse for an XLR to import the data from. For this, I've got this button mapped to just some default attributes. And once selected, you can either place this data just at the origin or at the user-defined point, which would just be wherever we click after we click OK. But we'll just put it at the origin of the footprint for this demonstration. And there you can see it's placed those attributes there. Now the only other thing that we might need is some dimensions for this footprint. A good first, to do this, you come up to the toolbar here and select the dimension mode. And from here you will click and drag to another, since I have the snap turned on the grid, you can see it snapping to the different snap points. So to start with, we'll just go with the size of the body, which you can see is coming up as 5 millimeters since we scaled it in the beginning. That's a good thing to see that it's coming up as the right dimension. And once we'll do this between the center of these pads, once you click and drag to another point, once you release, um, it gives you the option to drag how far out you want the dimension to be placed, and then you simply click to place the dimension. And you can do this horizontal and vertical dimensions. You can also, for example, if we wanted to go um, from the corner of that heat tab to the other corner, it gives us, actually let me zoom out a little bit here and make it a little easier to see. If we drag horizontally, it'll give us the vertical dimension, or if we drag vertically, it'll give us the horizontal dimension. But if we drag just perpendicular, it'll give us the true dimension between the two points that we've selected. Um, so it's a pretty versatile dimensioning tool that'll allow you to dimension the part. The last thing that I think we have not covered is actually naming the footprint, which is accessible under that footprint toolbar, and we'll just give it a name of sample. And I think that would do it. That gives us a pretty good footprint using the data from the data sheet. I hope this video was helpful. Thanks.